In the summer of 2003, a spacecraft rose from Earth carrying something far more fragile than it looked. Its destination was Mars, and inside was a rover designed for a mission so short that most engineers barely dared to dream beyond it. 90 souls, that was the plan. 3 months on another planet. But what followed would become one of the most emotionally powerful stories in robotic space exploration. Spirit was never meant to become a legend. It was built to roll, analyze rocks, take pictures, and eventually fall silent. Instead, it refused to stop. It crossed alien ground, survived seasons no one expected, and sent back images that even NASA wasn't prepared to see. This is the story of how Spirit reached its final moments on Mars and why its last photos still matter. Spirit was part of NASA's Mars Exploration Rover mission, paired with its twin, Opportunity. Together, they were sent to answer questions humanity couldn't yet ask in person. Did Mars once have water? Did it have a climate capable of supporting life? What stories were locked inside its rocks? And could robotic explorers prepare the way for humans who might one day follow? Spirit was a rolling laboratory, about the size of a golf cart, powered by sunlight and driven by code written millions of kilometers away. It carried panoramic cameras, navigation cameras, spectrometers to read mineral fingerprints, magnets to capture dust, a microscopic imager to examine grains smaller than sand, and a grinding tool capable of cutting into Martian rock to reveal untouched interiors. Even parts of its structure carried symbolic weight, incorporating metal recovered from the ruins of the World Trade Center, linking Earth's tragedy with humanity's curiosity. The rover's name came from a child, 9-year-old Sophie Collis, whose words about hope and dreaming captured the spirit of exploration better than any engineering document ever could. When Spirit launched from Cape Canaveral in June 2003, it entered a journey of nearly 7 months through interplanetary space. Course corrections nudged it toward a narrow target, but landing was the real trial. Entry, descent, and landing would compress years of planning into 6 minutes where everything had to work perfectly. Spirit slammed into Mars's atmosphere at nearly 19,000 kilometers per hour, heat built to temperatures capable of melting steel. A parachute snapped open in an atmosphere barely thick enough to matter. Rockets fired, airbags inflated, the rover bounced, rolled, and finally came to rest inside Gusev crater. On January 4, 2004, Spirit was alive on Mars, and almost immediately it began to see things no human had ever seen before.
Once Spirit unfolded and touched Martian soil, its cameras began stitching together the first color panoramas from the surface. These images weren't just photographs, they were reconstructions of an alien horizon built from multiple wavelengths and filters, revealing a world both familiar and utterly foreign. Gusev crater stretched out as a basin of rocks, hills, and dust, a place scientists believed might once have held a lake billions of years ago. Spirit rolled carefully, every movement planned in meters and degrees, navigating terrain where a single wrong angle could mean mission failure. Early on, trouble arrived. Just weeks after landing, Spirit suddenly fell silent. Communication dropped. When signals returned, the rover was trapped in a fault state, rebooting endlessly, draining power, and heating itself toward destruction. Engineers on Earth worked around the clock, diagnosing the problem across millions of kilometers. They isolated corrupted memory, reformatted the system, and brought Spirit back from the brink. It was a warning. Mars would not be forgiving. With systems restored, Spirit began its true work. Rocks became targets, each one a potential archive of Mars' past. After evaluating nearby candidates, the rover chose a rock named Adirondack. Using its abrasion tool, Spirit ground into its surface, performing the first controlled rock drilling ever conducted on another planet. What it revealed surprised scientists. The minerals told a story of volcanic basalt, similar to certain Earth rocks, but altered in subtle ways. The chemistry hinted that water had once interacted with these stones, perhaps briefly, perhaps long ago. It wasn't proof of life, but it was evidence of conditions that might have allowed life to exist. As Spirit moved deeper into Gusev, it examined more rocks, each adding detail to Mars' environmental history. Humphrey Rock showed signs of mineral deposits formed in the presence of water. Bonneville Crater revealed a landscape shaped more by impacts than erosion. Spirit avoided dangerous slopes, navigated dunes, and began the long trek toward the Columbia Hills, a rise on the horizon that promised older, deeper geology. But age was catching up. One of Spirit's wheels began drawing too much power, a sign of mechanical failure. Engineers adapted, commanding the rover to drive backward, dragging the damaged wheel to preserve the rest of the system. This improvised solution extended Spirit's life and turned a flaw into a new way of exploration. As dust settled on its solar panels and Martian winters loomed, Spirit adjusted its posture, angled itself toward the sun, and conserved energy. Against all expectations, it kept going. By its first anniversary on Mars, Spirit had already exceeded its mission many times over. And yet, the most unexpected discoveries were still ahead.
Climbing the Columbia Hills pushed Spirit into terrain unlike anything it had faced before. Slopes became steeper, soil grew softer, energy budgets tightened as dust dimmed the sunlight. But then Mars itself intervened. Dust devils swept across the landscape, cleaning Spirit's solar panels in sudden bursts, restoring power and granting the rover something like a second wind. With renewed energy, Spirit reached higher ground and captured panoramas that revealed Gusev Crater in stunning detail. From these vantage points, scientists could trace layers, textures, and patterns shaped by forces active billions of years ago. Along the way, Spirit encountered Comanche, a rock rich in carbonates at levels far higher than anything previously seen on Mars. Carbonates form in the presence of water that is not highly acidic, suggesting that Mars once hosted more neutral, potentially habitable environments. This was a turning point. Mars was no longer just a dry volcanic world. It had complexity. It had chemistry that resembled places on Earth where life thrives. As Spirit descended and continued its journey, mechanical failures worsened. The front wheel eventually locked completely, forcing the rover to drag it across the surface. What seemed like a limitation became an accidental tool. As the wheel scraped through soft soil, it exposed something bright beneath the red dust: white silica. On Earth, silica deposits are commonly associated with hot springs or hydrothermal systems, environments rich in microbial life. Spirit had not found life, but it had uncovered some of the strongest evidence yet that Mars once had places where life could have survived. And it found this not by design, but by persistence. As months turned into years, storms grew stronger. Dust filled the atmosphere, blocking sunlight. Power levels dropped dangerously low. Spirit's operations slowed to survival mode. Communication became sporadic. The rover experienced memory issues, long pauses, and unpredictable behavior. Eventually, Spirit reached a place called Troy, where its wheels sank into soft, unforgiving soil. Engineers tried every strategy to free it, simulating maneuvers on Earth, rewriting commands, pushing the rover gently forward and back. Nothing worked. In 2010, Spirit was reclassified as a stationary science platform. Even then, it continued to collect data, taking its final images, measuring the atmosphere, and sending what little power it could spare back to Earth. But winter was coming again, and this time, Spirit would not survive it.
As sunlight faded during the harsh Martian winter, Spirit's batteries slowly drained. Power dropped below the threshold needed to keep its electronics warm. One by one, systems shut down. Sometime in early 2010, Spirit entered a low-power fault from which it would never wake.
There was no explosion, no final transmission announcing the end, just silence. On a cold, empty planet, a machine that had outlived every expectation simply stopped. Spirit's last images were not dramatic in the way movies teach us to expect. They showed dust, soil, subtle changes in light. But to those who understood the journey, they carried enormous weight. These were the final glimpses from a traveler that had crossed 7.7 kilometers of alien terrain, survived 3 Martian winters, and sent back over 128,000 images. Images that rewrote textbooks. Images that showed Mars as a world shaped by water, chemistry, and time. Spirit's mission transformed our understanding of the Red Planet and reshaped how NASA designs future explorers. Its legacy lives on in perseverance, in curiosity, and in every rover that now carries lessons learned from Spirit's struggle and success. Even an asteroid now bears its name. But perhaps the most enduring legacy is emotional. Spirit was a robot, yet people around the world mourned its loss. Because Spirit embodied something deeply human: curiosity, resilience, the refusal to give up even when the odds say you should. The rover, named by a child who once dreamed of escaping darkness and cold, ended its journey alone on another world under a sky filled with stars. It never knew applause, it never knew fame, but it changed how humanity sees Mars. And it proved that even machines, when driven by human hope, can leave behind stories that feel alive. NASA may not have been ready for Spirit's final photos, but the world was changed by them. And long after the dust settled over Gusev Crater, Spirit's quiet legacy continues to inspire the next steps into the unknown.